My name is Dr. Stephan Tait. I work for the Centre of Agricultural Engineering at the University of Southern Queensland. The two activities that I was involved with and led looked predominantly at separating manure for its value and also to recover energy from that as biogas. I supervised Torben Grell. Torben went all around the country, sampled dairy manure from dairies of different types, and we analysed that dairy manure for its methane productivity. One of the systems that we use in our lab measures the amount of methane or biogas that can be produced from manure. It's comprised of three main parts. It's the digestive part, where we put manure, mix it together with a microbial inoculum. Then there's a component that takes out the carbon dioxide that's being produced by the microbes that are growing, and that leaves the methane component, which is then ultimately measured using a counter flow meter. This information tells us about how much biogas we can produce from a set amount of manure, and it also tells us a little bit about how rapidly that biogas can be produced. And through this project, we were able to provide real, scientifically rigorous data that could be used in, say, the Australian national greenhouse gas accounts. Prior to this project, Australia actually didn't have that data or information available at all. And without this information, we really are unable to forecast how much benefit can be extracted from the manure on these farms. We conducted separate experiments, and there we're measuring things like how much gas is produced when we change operating conditions like temperature or the amount of manure that we feed to the digestion system. The literature suggested that when you have a particulate material like manure, that its overall conversion into biogas would be limited by the microbial step of hydrolysis. The way we went about investigating this is we progressively increased the amount of manure that we fed to our bench scale digesters, and then we explored how much biogas could be recovered. The importance of us finding that our dairy manure digesters could be loaded up to a fairly high organic loading rate without seeing pH depression or microbial stress issues, it indicates that on-farm digesters would be perhaps more resilient than what we previously thought. If we can somehow enhance that hydrolysis process, we can increase the amount of biogas that we can produce over a very short amount of time. And this is important because our digesters can be smaller. We can potentially produce more biogas from the manure. Also interested in knowing what that biogas is comprised of, so how much methane and how much carbon dioxide is in there. The methane being the energy component that can be utilised on farm. And so for that purpose, we use a handheld biogas composition meter, which we then measure the biogas composition with. We also track the amount of biogas that's being produced using a biogas flow counter meter, similar to what we use on our methane productivity test set. And lastly, we take some manure samples prior to feeding the digestion system and some digested material coming out of the digester. And that tells us about the composition of the digester contents itself. For example, what microbial organisms are present inside the digester, but also how effective the digestion system is in terms of converting the manure into biogas. Biogas is available 24/7. It's a sustained energy supply for on-farm use. It doesn't vary over time in its availability. It means it's an excellent baseline source of energy for on-farm use. Our results are already being used for evaluating the economic feasibility of biogas in the dairy sector in Australia. One of the things we found is that there's potentially very viable projects at intensive dairies. The amount of manure that's captured translates into a higher energy potential, and it meets the demand for energy at those farms very well. As we see our dairy sector in Australia progressively move from extensive grazing more indoors to intensive systems, we want to assist the industry to make that transition sustainably and to implement technologies and practices that maintain the overall green operation of that sector as it has been in the past.